We're going to talk about changes and properties. So a physical change. A physical change is one that alters the state, solid, liquid, or gas, or appearance of the substance, but it doesn't change the composition. So the example given here is water boiling. So here we have liquid water, and this is what the molecules look like. They always remind me of Mickey Mouse, these little Mickey Mouse heads, and they're very close together. We heat this up, it boils, it goes into the gas state, floats through the air, and escapes. The individual particles are the same though. They are still water molecules. What has changed is now they are separate from each other. When class is out and you guys go through the door and you go off to the rest of your lives, do you lose an arm? Does your head fall off? Does your skin turn green? No, you look just the same. The difference is that you're further apart from the rest of us, right? The individual person doesn't change. So the particle doesn't change in a physical change. In a chemical change, the particle does change. Example here is the rusting of an iron nail. So here we have iron atoms in the nail, and when it rusts, it interacts with oxygen, and the oxygen comes in between the iron atoms, and now we don't just have iron atoms anymore, we have iron and oxygen. The particles have changed. And so this is a chemical change. When you have a chemical change, the initial substance is destroyed and new substances are formed. Some examples. Dry ice, solid carbon dioxide. So this doesn't melt, it sublimes. It goes directly to the gas state. That's why it's dry, because regular ice melts and gets wet, right? This ice doesn't get wet, so we call it dry ice. So here are the particles in the dry ice, carbon dioxide molecules, and when it goes into the gas state, they just separate. It's a physical change, the particles are the same. Sugar dissolving. You take a teaspoon of sugar, put it in a glass of water, you stir it up, seems to disappear. Here are the sugar molecules in the dry sugar. You put them in the water, they separate from each other and they mix up with the water, but the individual particles are the same. That's a physical change when you dissolve one thing in another. If we let all the water evaporate out of this sugar and water mixture, the sugar is still there. It will still be sweet and have the same characteristics. So that's a physical change. This is a chemical change, propane burning. So here in this little propane cylinder, we have propane molecules. They look like that. When we let them out and have air present with oxygen and we get it started, it burns, and these propane molecules combine with oxygen from the air and they make carbon dioxide and water molecules. So these particles don't exist anymore, and we've got new ones that weren't there before. That's a chemical change. Any questions? So those were changes. We also talk about chemical and physical properties. You can demonstrate or observe a physical property without destroying the stuff. You could measure its mass, you could measure how long it is, you could observe its smell or its color. Other examples are melting point and boiling point. You can measure the density. Those are physical properties. A chemical property, in order to demonstrate or observe that chemical property, it has to undergo a chemical change. Basically, chemical properties are descriptions of chemical reactions that can occur. So gasoline is flammable. If we demonstrate that, if we observe that gasoline burns, just like the propane burning, that's a chemical change. The gasoline isn't there anymore. It's gone into carbon dioxide and water. We've destroyed the substance. That's a chemical property. Other examples are corrosiveness, acidity, and toxicity. Okay, so here's an example. Determine whether each change is physical or chemical. What kind of property is demonstrated? So we take a copper wire and we bang on it with a hammer and we flatten the copper wire. Does that change what the particles are made of? No. They're still copper atoms. We're just squishing them into a different form. So is that a chemical change or a physical change? That's physical. Oh, that was the wrong pen. That was my sand pen. So that's a physical change. Is that property that you can hammer copper flat, is that a physical property or a chemical property? It's a physical property. Physical property goes with physical change. Chemical property goes with chemical change. We take a nickel, 5 cents, throw it in some acid, and it dissolves, the nickel is gone, and now we have a blue-green solution. Is that a physical change or a chemical change? That's a chemical change. We have changed the particles involved here. In the nickel, we had nickel atoms arranged, and now when we put it in the acid, it reacts and recombines, and now we've got nickel ions in the solution, and they have this blue-green color. Is that description of a chemical property or a physical property? It's a chemical property, because to demonstrate it, you have to destroy the stuff. Okay, dry ice sublimes without melting. Is that chemical or physical? Physical. I'm not sure why they put that one in there, because we just had that nice illustration of it. How about a match ignites when struck on a flint? Chemical. So that match, you strike it on a flint, it bursts into flames, and then you blow it out before you burn your fingers, right? Could you do it again? Is the match going to work anymore? No. It's been changed. And if we think about it, we understand that the individual particles that make up that match have been changed. Any questions?